Finally, the squeeze theorem. So for the squeeze theorem, you'll be just asked to solve a limit. Let's say it says the limit as x goes to 0 of x squared multiplying sine 1 over x. And you're supposed to get this. So basically, all you got to do is the squeeze theorem will be saying, we cannot find this limit directly, okay? We can't. But what we can do is we can find the limit by knowing. You know, it's like you have things like this. If you have a function like this, and then you have another one which goes like that, and then does that, and then whatever it does, you know. Now, if you see these two functions, I'm going to put the x's here like this. All right, if you see these two functions, this is the function y is equal to f of x, and here is a function which is y is equal to g of x. Now, if you see these two functions, g of x is always below f of x. If we now come with a third function which is coming like this, a function which is always going to be in between, which is always going to be in between these two functions that we have, and we can call this function y equal to h of x. Now, this function y equal to h of x, if it is always going to be between f of x and g of x, that means that if you ever find a point, a special point like this point where x is equal to c, so here is the value of c, and if you ever find this point where the two graphs y f of x and y g of x are together, in other words, they're giving you the same limit, they're giving you the same y value called L, then h of x, which is in the middle, will have to give you the same limit. We are saying that we can't find the limit of this middle guy, h of x, directly, right? But then what we can do is look for the point. We are trying to find the limit as x goes towards c, right? If c is a special point like this one, where this graph of g of x was always below all the graphs, this graph of f of x was always above all of them, and h of x is always in the middle. So if you get to a point where the one which is below and the one which is above are giving you the same limit, then automatically the middle one will have to be giving you that same limit, because this middle one, the orange one, cannot do this, cannot go below this value here. It can't, because if it goes below this value, it is now below g of x, because g of x will be here. And it can't go above, because if it goes above, it is now above f of x, which can't happen. It is always supposed to be in between. So that means it will also have to pass through this point where all limits are the same. So if we can find the limit of g of x and find the limit of f of x, if these two limits are ever the same, remember limit is the y value. If they ever give me the same y value, that means the middle one, since it is in the center, it will also have to give me that same y value, to mean that all three of them are meeting at that point. The middle one cannot give you a value lower or higher, okay? That is what we are saying. Now, let's do it. So when you are solving it as a question, you'll be having something like this. Now, the moment you see, and there'll be the graph of sine or the graph of cos, okay? Now, the graph of sine, we don't care what it is, sine 1 over x or sine x squared or sine x cubed or sine whatever. Any graph of sine, wherever it is sine, in this case it is 1 over x. It always is from minus 1 up to 1. Any graph of sine. Any graph of sine. We don't care what it is sine of. Now, if you see here, we are having it multiplying by x squared. So which means if you are doing it, you are stretching by x squared, which means you have to come this side, multiply by x squared, and come this side and multiply by x squared. So it becomes negative x squared less than or equal to x squared sine 1 over x, which is less than or equal to x squared times 1 is going to be x squared. So now you have made an inequality, and you are proving that this guy, which you are finding the limit of, is actually between him and him. So now all you're going to do is, we are getting the limit as what? X goes to 0. So you're going to find the limit as x goes to 0 of this, and the limit as x goes to 0 of that. If their limits are ever the same, that means this middle one will have to be that limit as well, because it's the middle, so it can't go above or below. If the two limits are the same, that means we are at that point where the two graphs were meeting. That means the middle one will also have to come through that point and give us the same value. So that is what happens. So that is what we are now saying. So you say, I'll find the limit of the left, limit of the right. I can't find the limit of the middle. It's impossible. So I'll find the limit of the left. Limit as x goes towards 0 of negative x squared. And here where there is near x, I'm putting 0. So it's negative of 0 squared. Anytime when you have a 0, answer is 0. Then we can now say, what about the limit as x goes to 0 of x squared itself? This is a polynomial, so we substitute. Where there is x, we're putting 0. So it just becomes 0 squared, which is still 0. So you can say that these two limits are the same. So you can now say, since the limit as x goes towards 0 of negative x squared is equal to, you can first say, since you say negative x squared is less than or equal to x squared sine 1 over x, which is less than or equal to x squared. You're showing them that this guy is in between him, and we have seen that. And you can now say the limit as x goes to 0 of negative x squared is equal to the limit as x goes to 0 of x squared, which is equal to 0. Okay, they found the same answer, which is 0. You can now say, therefore, by the squeeze theorem, okay, by the squeeze theorem, you can now say that limit as x goes to 0 of x squared sine 1 over x is equal to 0. So the middle guy will also have that same limit, and you are done. This is what you do with the squeeze theorem. Okay, you just make up this range. This is the secret. You have to make this range. And this range, remember, whatever cos, this one, whatever sine or cos, okay, you'll be having sine and cos. They always start at -1 and end at 1. Then you then bring in whatever. If it's multiplying, you multiply. If it's dividing, you would have said -1 over x squared, then here 1 over x squared. That is if it was dividing, whatever it is doing now. But you start with this one because you should know it's the range. Then you can change whatever. And now you can find the limit of the in-between by finding the one on the left and the one of the right. Okay, so this is what you'll be having, and that is the squeeze theorem, and it's not even hard, right? It's not. Now we can go to trig. Now we are getting into nice territory. Let's keep going. Goodbye for now.